Hey everyone, today we are going to solve the Daily LeetCode challenge of 22nd March 2024 and the problem statement is Palindrome Linked List. So let us first understand the problem statement. So according to the problem statement, we have been given a linked list and we have to determine whether it's a palindrome or not. Now what is a palindrome? A palindrome is something that reads same from backward and forward. Reads same from forward and backward. Okay, let us take an example of a string. Okay, so if I have been given a string as 1, 2, 2, 1. Now, if I will read this from the forward, then what I'll get? I'll get 1, 2, 2, 2, 1, correct? 1, 2, 2, 1. And if I read the same string from backward, what I'll get? I'll get 1, 2, 2, 1. I'll get 1, 2, 2, 1. So are these two equal? So these two are equal. That is, these two are same. So what does it mean? It means that this is a palindrome. Now let's take another example. If I have been given a string like 1, 2, 3, 1. Okay. So what is it if I read this from forward? It would be 1, 2, 3, 1. Correct. And what it would be if I read it from backward? It would be 1, 3, 2, 1. Now, are these two equal? The answer is no. So is this a palindrome? This is not a palindrome. Why? Because it does not read the same from forward and backward. Correct. Now, if we have been given a string or an array, then how do we check whether it's a palindrome or not? So let's see. If we have been given a string as 1, 2, 2, 1, then what we can do is we can take two pointers and we will place the first pointer at the 0th index. Let's say this is start, and we will take another pointer at the end of the string, that is at the last index. So let us say this is end. Now what we'll do, we'll check, are these two equal? So these two are equal. So what we'll do, we'll move the start forward, okay, and we'll move the end backward. Okay, now we'll check, are these two equal? So these two are equal. So what we'll do, we'll move the start forward one step and we'll move the end backward one step. Now the moment our start will become greater than end, then what does it mean? It means that the start has processed all the elements from front to forward to the mid, and the end has also processed all the elements from backward to the mid. Now since we have processed all the elements and we didn't found any of them which is not equal, so what we'll do, we'll simply return true, stating that this is a palindrome. Now let's check for the case when we don't have a palindrome. So what we can do, we have 1, 2, 3, 1. Here is our start, here is our end. And what we'll do, we'll check that the value at start and end are equal. So we will increment start and we will decrement end. Now we'll check that the value of start and end are not equal. So what does it mean? It means that it's not a palindrome. So we'll simply return false, indicating that it's not a palindrome. So this is how we will check whether a string or an array is palindrome or not. Now, will the same logic apply in case of a linked list? So the answer is no. Now you may ask why. So the first reason is that in case of this string, what we were doing, we were placing a pointer at the very first element and we were placing another pointer at the very last element. Now, do we have the access of the very last element? Or do we have the address of the very last element? The answer is no. But you may also say that, okay, what we can do is we can traverse the entire linked list and we'll be able to reach the very last element and we can get its address, correct? So, okay, even though if you get its address, then what we were doing here, we were having the start pointer and end pointer, and whenever they were equal, we were moving start pointer forward and we were moving end pointer backward. Okay, so if we will take a start pointer over here, we can move it forward, no doubt. But if we have an end pointer over here, can we move it backward? The answer is no. Why? Because in case of this single linked list, we can only move in one direction, that is in this forward direction. We can't move in the backward direction. So we can't use the same logic over here. Or maybe we can use it over here, but not directly, not in this way. That is by using start and end pointer and moving one forward and moving another backward. We can't do that. Okay, now that we have discussed at why did the previous approach didn't work in this case, it's because we can't move backward. We can only move forward, correct? So can we have an approach in which we will only move forward and we will be able to check whether the linked list is palindrome or not? So let's see. So for finding this problem, we will first find out the middle of the linked list. So what is the middle of the linked list? In this case, we can see that this 3 is the middle of the linked list. Okay, so we have got the middle of the linked list. Now, once we have got the middle of the linked list, what we will do is we will reverse the entire part starting from the middle of the linked list to the end. So if we will reverse this part, then what we'll get? We'll get 1, 2, 1, 2, 3. Correct? Because what we did, we reversed this part. Correct? So if we'll reverse this part, what we'll get? We'll get 1 over here. Then we'll get this 2. Then we'll get this 3. Correct? So what we have added over here, we were having this 1, we were having this 2, and once we have reversed this part, what we got this one, correct? That is 1, 2, 3. Okay. Now first what we did? First we did that we have to find the mid. First step, what was the first step? First step was find the middle or mid of the linked list. I'm representing linked list as LL. Okay. Now, once I have found out the linked list, what we did in the second step? In the second step, we reversed from the middle, right? So what we did? Reverse linked list from mid to end, correct? We reversed it starting from the mid position to the end position, correct? Now, once we have reversed it, what we will do is in this third step, we will take 2 pointers such that our first pointer would be at this one. So let's say this is start pointer, and another pointer would be at this mid, correct? So let's call this as mid. Fine. Now that we have reversed this part, and we have got this part, so in this case, our mid would be the new element, right? Earlier our mid was 3, now our mid would be 1, correct? Why? Because this 1 and this 3 have changed or exchanged their places, correct? So this would be our new mid. Now what we will do is, we will check until our start is not equal to this mid position. Let us store this mid position in some another variable as well. Let's call it as temp. Okay. So until our start is not equal to temp, what we will do, we will check that whether the value of start and mid are equal. Yes, they are equal. So what we'll do, we'll move this as forward, and we'll move this at forward as well. Now we'll check, is the value of start and mid equal? So the value of start and mid are equal. What we'll do, we'll move this forward, and we'll move this forward as well. Now we can see that our start has become equal to temp. So we will come out of the while loop and we'll simply return true. Why? Because until the start was not equal to temp, we didn't got any of the two values that were not equal, correct? That's why we will be returning true in this case. So let's take another example as well in which the linked list is not a palindrome. So if we have 1, 2, 3, 4, and 1 again. Now what we did in the first step? In the first step, we found out the mid. So what is the mid of the linked list? The mid is 3, correct? So we have got the mid. Now after that, what we have to do? We have to reverse linked list from mid to end. So what we have to do? We have to reverse this part. So what we'll get? We'll get 1, 2. And once we reverse this part, what we'll get? We'll get this 1. After that, we'll get this 4. And lastly, we'll get this 3. Correct? Now, once we have reversed it, what we have to do? We have to place a pointer at the start. We have to place a pointer at the mid. Let this be m. And we will also store this mid in another variable. Let's call it as temp. And we will say that while this start is not equal to temp, what we have to check? We have to check whether these two values are equal or not. So we'll check. Is the value at start and mid equal? Yes, they are equal. So what we'll do? We'll move this forward and we'll move this forward as well. Now we'll check. Is the value at start and mid equal? Now we can see that the value at start and mid are not equal. So what does it mean? It means that it's not palindrome. So the moment we'll get that the value at start and mid are not equal, we'll simply return false, stating that it's not a palindrome. Additionally, we can also see in the original linked list that this is not a palindrome, right? If we read this from forward, what we'll get? We'll get 1, 2, 3, 4, 1. And if we read this from backward, what we'll get? We'll get 1, 4, 3, 2, 1. Are these two same? These two are not same. So now that we have understood that what all 3 steps we are going to do, now let's understand individual steps. That is how we can find mid of the linked list and how we can reverse it and how we can follow the third step, that is checking for palindrome. How we can do these 3 steps, correct? So let us first discuss the first step, that is how we can find the mid of the linked list, correct? So for finding the mid of the linked list, what we can do is we can place a pointer over here. Let this pointer be slow. And we'll place another pointer over here. Let this pointer be fast. And we will say that while this fast is not equals to null and fast next is not equals to null. Okay, until then what we will do? Until then we'll move slow by 1 step and we'll move fast by 2 steps. So what does moving slow by 1 step means? It means that we'll set slow as the next of slow and we will set fast as the next of next. Correct. So let's see. So currently our slow is over here and fast is over here. So we'll check. Is that fast null? No. Is the next of fast null? No. So what we'll do, we'll move slow by 1 step. So our slow will point at 2. And what we'll do, we'll move fast by 2 steps. So what does fast next means? So what is fast next? Fast next is 2 and its next is 3. Correct. So fast has moved by 2 steps and it's pointing at 3 right now. Fine. Now what we will do, we'll again check, is our fast null? No. Is the next of fast null? No. So what we'll do, we'll move slow by 1 step and we'll move fast by 2 steps. So what have we done? Our slow will now point at 3 and our fast will move by 2 steps. So what is the next of 3? The next of 3 is 2. And what is the next of 2? The next of 2 is 1. So now our fast will point at 1. Correct? Now again we will check, is fast null? So fast is not null because it's 1. Is the next of fast null? So what is the next of this one? The next of this one is null. So the next of this fast is null. So what will happen? We'll come out of this while loop. And the moment we'll come out of this while loop, we can see that this slow pointer is pointing at the mid of the linked list, correct? Which is 3. So this low is pointing at the mid. Now what we have to do? Now that we have got the middle of the linked list, we have to follow the second step, that is reversing the linked list. But before reversing the linked list, let me also tell you one thing, that once we will reverse this part, then what will happen? If we will reverse this part, then this link will get broken. Then we will lose this entire data, correct? So in order to preserve this, what we have to do is we have to keep another pointer previous, which would be here as of now, correct? So what we will do after reversing this part, we'll simply set the next of previous at the reversed part, correct? So what we did in the first step, we move slow by 1 step and fast by 2 step until when? Until fast is not null and the next of fast is not null. Until fast not null and fast next is not null, correct? This only we did. So if we come out of this while loop, at that point what will happen? Slow points at mid, correct? Slow is pointing at mid. So this is what we did in the first step. Now let's see how we can actually reverse this linked list from the mid to end. Okay, so which part do we have to reverse? We have to reverse this part. So let me write it over here. We have 3, we have 2, we have 1. Correct. So what is its reverse? Its reverse means we have to reverse the link. So since here we have a link from 3 to 2, then in the new linked list, what will happen? We will have a link from 2 to 3, correct? Here we have a link from 2 to 1. Then in the reverse linked list, what we will have? We will have a link from 1 to 2, correct? We have reversed these links. So what does it mean? It means that in the resultant linked list, what we have to do? We have to set the next of 3 as null, right? We have to set the next of 3 as null. Correct? So if we will set the next of 3 as null, then what will happen? This link will get break. So if this link will break, then what will happen? We will lose these all data, right? So in order to preserve these all data, what we will do is we will store this data in a variable called next. And currently we are over here, so let's name this as current. And since we have to set the next of 3 as null, so let's take another pointer for that. Let's call it as previous. Okay, so let's see how are we going to do this. So first of all, what we have to do, we can see in this linked list that the next of this 3 is null. So first of all, what we have to do, we have to set the next of this 3 as null. So what does the next of 3 mean? The next of 3 means the next of this current. So we have to set the next of this current as what? So null is stored in previous. So we will set the next of current as previous. So what will happen? This link will break and we will have a new link that is like this. So 3 will now point at null. Okay. And we have this entire thing in next, correct? Now this link is broken. Correct. Now we have created a link from 3 to null, right? Now what we have to do, we have to create a link from this 2 to 3. So what we will do, we will move all this pointer by 1 step. So our previous will now point at the current element, that is at 3. Our current will point at the next element, that is at 2. And our next pointer will also move by 1 step. So it will point at 1. Fine. What we did, we set previous as current. We set current as next. And what did we did? We set next as the next of next. Correct? Fine. Now what we have to do, we have to create a link from 2 to 3. So if we will set currents next to previous, then what will happen? We have 2 in current and 3 in previous. So if we will set currents next to previous, so we will create a link like this and this link will break, right? So this link will break. And we have got a link from this 2 to 3, correct? We can see that in the resultant linked list, we had a link from this 2 to 3. So we have got a link from this 2 to 3. Now what we'll do, we'll move all these 3 by 1 step. So our previous will now point over here. Our current will point at 1 and our next will point at null, correct? Now what we'll do, we'll see that we have a link from this 1 to 2. So what we have to do, we have to set the ones next as 2, that is we have to set currents next as previous. So if we do like that, what will happen? We will get a link like this. Correct? And after that, what we have to do, since we have created a link like this, we have to move all these 3 pointers by one step. So our previous will now point at 1, our current will point at null, and we can see that our next pointer is already null. So we can't move it forward, right? If we will say that set next as the next of null, so it will give you a runtime error. That's why before moving this next pointer, we have to add a check. That is, if next is not null, right? If we have next on, then only move the next pointer, correct? So now we can see that our current has become null. So what does it mean? It means that we have processed all the elements of the linked list, and we can see that the linked list which we have got is the reversed linked list, correct? That is this one. So it means that we have successfully reversed it. And what is the head of the new reversed linked list? It's previous, correct? Because we can see that previous is pointing at 1. Now, once we have got the reverse linked list, what we have to do, we have to add this reverse linked list over here, that is over the next of 2. So let's add this. So what will happen? Let's remove this all. So we have to set this reverse linked list after this 2. So what we will have? We'll have this 1 over here, we will have this 2 over here, and we'll have this 3 over here, correct? Now we are done with the second step, that is reversing the linked list from mid to end. What was our mid? Here our mid was 3 and end was 1, and we reversed them. Now our mid is 1 and end has become 3. Now what we have to do, we are done with the second step. Now we just have to do the third step, that is checking for palindrome. And how are we going to do that? We will be placing a pointer over at 1, let's call it as start, and we will place another pointer at 1, let's call it as mid, let me represent it as M, and we will have one more pointer at 1, let's call this as 10. Okay, so what we'll do, we will say that until the start is not equal to 10, what we have to do, we have to move both start and mid by one step, and we will check that if the value of mid and start are equal, then we'll simply move them forward. And if the value of mid and start are not equal, then what we'll do, we'll simply return false, indicating that it's not a palindromic linked list. So let's check, is the value at start and mid equal? So the value at start and mid are equal, so what we'll do, we'll move both of them by one step. So start will point at 2, mid will point at 2. Now we'll check, is the value at start and mid equal? So the value at start and mid are equal, so what we'll do, we'll move start by one step and we'll move mid by one step. So we can see that start has become equal to temp. So what will happen, we'll come out of this while loop, and since until start was not equal to temp, we didn't got any value which was not equal, right? We didn't got any value at start pointer and mid pointer which weren't equal. So what does it mean? It means that this linked list is a palindrome. So what we'll do, we'll simply return a true. Okay. So now I hope that this is clear to you all, that first what we are doing, first of all, we are finding the mid of the linked list. And how are we doing this? We are doing this by using 2 pointers, slow and fast, such that slow is moving one step and fast is moving by 2 steps until our fast is not null and the next of fast is not null. And the moment any of these two condition becomes false, what will happen? We will come out of the while loop and we will see that slow will point at the mid of the linked list at that very moment, correct? Now, once we have got the mid of the linked list, what we have to do? We simply have to reverse that linked list, right? From mid to end. And how are we going to reverse it? We are going to reverse it using 3 pointers, current, previous, and next pointer. Okay, and what we will do, we will simply set the next of current as previous, and once we have done that, we will move all the 3 pointers, and the moment our current will become null, at that very moment our previous would be pointing at the head of the new linked list, correct? Now once we have done reversing the linked list, what we have to do, we have to check whether they are palindromic or not. And how are we doing that? We are doing it by using 2 pointers, start and mid, such that start will be pointing at the starting of the linked list and mid will point at the new mid of the linked list. And we'll say that until the start is not equal to 10, we have to check their values. If their values are equal, we'll simply move them forward. If their values are not equal, it means that it's not a palindrome and we'll return a false. Okay. So if you still have any doubt in finding the mid of the linked list or in reversing the linked list, then I have created a separate video for both of these problems. That is for finding the mid of the linked list and for reversing the linked list. So I'll be adding it in the I button. You can click over there, or I can also add it in the description. You can check for the link and you can view that video as well. Okay. So now that we have understood all the 3 steps that we'll be using for solving this problem, let's quickly code this. Now, first of all, what we'll check that if the next of our head is null. In that case, what we'll return? We'll simply return true. Why? Because what does this mean that the next of this head is null? It means that we have only one node in our linked list, that is something like this. So if we have only one node in our linked list, then it's always a palindrome, correct? Now, what was our first step? Our first step was to find the mid of the linked list, right? Step 1, find mid of linked list. Now, how do we find the mid of linked list? So we will take 2 pointer. First pointer would be slow, which will point at the end of the linked list. Another pointer would be fast, which will also point at the end of the linked list initially, correct? Now, what we have to do, we'll take one more pointer. Let's call it as before slow, and we will set this as head as well, correct? Now, what we'll check? We'll check that until our fast is not null and the next of fast is not null. Then what we will do? We will simply move the slow pointer by 1 step and the fast pointer by 2 steps. So what we'll do, until fast is not null and fast next is not null, then what are we going to do? We are going to move slow pointer by 1 step. So we'll set slow as the next of slow and we'll set fast as the next. Correct. Because fast is moving by 2 steps. But before setting the slow as the next of slow, what we have to do? We have to set before slow as slow. Now, why are we using this before slow? It's because whenever we have a linked list and when we are going to find the mid of the linked list, so say for example, we'll get the mid of the linked list like this, right? Then after that, what we have to do? We have to reverse this entire part, right? Now, the moment we'll reverse this entire part, what will happen? This link will break, correct? So, and we will lose this entire data. So we don't want to lose this entire data. That's why before reversing this linked list, what do we want? We want a pointer which will point at this 2, and that pointer is named as before slow. So it simply represents that it is just 1 step before slow. And what we'll do, we'll set the next of this before slow as the reverse linked list, correct? Okay. Now, the moment we'll get that this fast has become null or the next of this fast has become null, then what does it mean? It means that our slow pointer will point at the mid of the linked list at that point. Now, what does it mean? It means that we have successfully found the mid of the linked list. So what we have to do, we have to follow the second step, which is what? Which is to reverse the linked list from mid to end. So what we have to do, we have to follow the step 2, which is what? It's to reverse linked list from mid to end, correct? And where is our mid? Our mid is at slow. So let me represent this as slow, correct? From slow to end, right? So slow is what? Slow is the middle of the linked list, correct? So what we will do, we will set the next of this before slow as, we'll create a function reverse linked list, okay? And what will pass over here? Will pass slow. Why are we passing slow? Because we have to reverse this linked list starting from this slow point, correct? So let's quickly write this function reverse linked list. So it will return us a linked list. So let's write list node over here, list node star reverse linked list. And what do we have? What we have passed? We have passed a list node. Let's call this as head. Okay. Now, how are we going to reverse the linked list? We are going to take 3 pointers, current, previous, and next pointer. Okay. So let's do it. So it will say that if our head is null, or if we get that the next of this head is null, correct? What does this mean? It means that if we have something like this, or if we have only one element, then what would be its reverse? Its reverse would be the head itself, correct? So in that case, we'll simply return the head. Otherwise, what we'll do, we'll create 3 pointers, previous, which would be initially null. We will take another pointer, current, which will initially point at the head of the list node. And another pointer would be next, which will point at the next of this current pointer. That is, initially it would be next of the head pointer, right? Now what we have to do, now until our current is not null, we will set the next of this current as previous. And once we have done that, we'll move all these pointer by 1 step, right? So we will say that while we have current, that is while our current is not null, what we have to do, we have to set the next of current as previous. And once we have done that, what we have to do, we have to move all these by 1 step. That is, we have to set previous as current, we have to set current as next, and we have to set next as the next of next. But in the dry run, we saw that this next may become null. So before moving this next pointer forward, what we have to check? We have to check that this next should not be null, right? Otherwise, it would give us a runtime error, right? Now, the moment this current pointer will become null. So what does it mean? It means that we have successfully reversed the entire linked list, right? And what do we have to return? We have to return previous. Why? Because this previous would be pointing at the new head of the reverse linked list, right? So what we will return from here? We will return previous, right? This would be next over here, okay? Sorry. Now that we are done with the second step in which we have reversed the linked list and we have added the reverse linked list to the next of this before slow, what we have to do, we have to just follow the third step, that is check for palindrome. That is whether this linked list is a palindrome or not. So what we will do, we will create a pointer which will point at the head of the linked list. Let's call it as start. So it will be equal to the head. and we will have another pointer which would be mid, that will point at the middle of the reverse part, right? So what would be the middle of the linked list? The middle of the linked list would be now the next of this before start. So let's set this middle as the next of the before start. Now what we will say that while this start is not equals to the next of this before slope. So what we will do, we will check that if the value of start is not equals to the value of mid, correct? Then in that case, what does it mean? It means that it's not a palindrome and will simply return a false. Otherwise, what we'll do? Otherwise, we'll simply move the start pointer by one step. That is, we'll set start as the next of start, and we'll move mid pointer by one step. That is, we'll set mid as the next of mid. Correct? Now, once we will come out of this while loop and we will get that this condition doesn't hold, then what does it mean? It means that it's a palindrome. So what we'll do? We'll simply return true. Okay. Now let's quickly run this. So it's giving us the correct answer. Let's submit it, and it got accepted. Talking about the time complexity and space complexity. So if we have a total of n nodes present in the linked list, then the time complexity would be order of n. Why? Because what we are doing in the first step. In the first step, we are iterating over the entire linked list in order to find its mate, correct? So what does it mean? It means that the first step is going to cost us a time complexity of order of n, correct? Now, what are we doing in the second step? In the second step, we are reversing the linked list starting from its mid position. Now, what does the mid position means? Mid position means we will be iterating over n by 2 elements, correct? If we have n nodes in the linked list, then we are iterating over n by 2 of the elements in order to reverse all those n by 2 elements, correct? So it means that this step 2 is costing us a time complexity of order of n by 2. And what is order of n by 2? Order of n by 2 is order of n only, correct? Now, what are we doing in the third step? In the third step, we are checking whether the linked list is palindrome or not. So for that, what we are doing? For that, we are taking two pointers. First would be start and the another would be mid. And what is the start doing? The start is moving forward. Like initially start was at 1, then start will move to this second element. And what is this mid doing? This mid is also moving by one step. So in the third step as well, we are going to iterate over all the n nodes of the linked list. So it will cost us a time complexity of order of n only. So order of n plus order of n plus order of n will give us order of 3n, which is order of n only, correct? Because 3 is the constant, so we can ignore it. And we are not using any extra space complexity from our end, because of which the space complexity would be order of 1. So that's all about today's daily LeetCode challenge. Thank you.